Thank you all for taking the time to do this. We're really excited today about this, the webinar that we're doing about the agentic era, the myths and realities of it all. It's actually the conclusion of our AI webinar series that we started back in September. This is the fifth one. Really excited to have Roy leading this one for us. Roy's a co-founder and CEO of Salt. But more than that, he's got a super impressive background that I wanted to share as we get into this. So Roy founded Salt with Michael Nicosia in about 2016, 2017. But prior to that, Roy was in the Israeli Defense Forces. You may hear it sometimes just abbreviated as IDF, and was in the cyber unit as a team lead, and took that experience and a lot of what he saw there, where he saw some real risks and some threats that weren't being covered from any of the security vendors, and said, I think there's an opportunity here. And from that, Salt was born. But even more so, Roy, a leader in the industry, helped and was really the main driver behind you probably are familiar with OWASP Top 10, but there's also a version of that that's the OWASP Top 10 that's specific to APIs. Roy was super instrumental in creating that. It's always interesting to hear him talk. I love working with him day to day. He's got this great mix of technical skills, real customer focus on solving problems, and great leadership skills. He's just a joy to be around in general, but very, very accomplished, and happy to have him here today. So, Roy, if you want to go to the next one, I'll give people a brief agenda, and then we'll get into it. But you guys, you can read this probably faster than I can. I can explain it to you, but we're going to start kind of at the high level of the market dynamics, what's going on with API Fabric, get into some of the key things that you want to ask, show some real world examples of what is going on in the agentic AI space and issues you should be concerned with or be looking at, and then some solutions to it as well. And then we'll wrap it up with a couple of the top myths and realities that we are hearing in the space specific to agentic AI and API security. So with that, Roy, I will turn it to you. Super happy to have you here. The stage
Thank you. Yeah, people will think I bribed you to say all of that. You managed to embarrass me a bit. So, but anyway, I appreciate the kind words. Just because I share in my screen, I cannot see, of course, anyone cannot see how even myself. So just want to make sure MC, sound, video, everything is okay.
It all, yep, sounds and looks good. All good.
Okay, great. So as going through it, I'm sure that while they have questions, there's I think the technicalities of where you put the questions, and obviously MC can jump in and surface the question. Also, we'll leave some time for questions at the end. I tried, like, our focus is, and my focus is, always try to provide as much as value as we can to you from our expertise for what we are seeing and so on and so forth, and kind of leave like any fluff aside. So anyway, so excited. So let's jump in. Okay, so the first thing is there need to look at the evolution of kind of what we call the API fabric, essentially all the APIs and how they communicated with each other of a company, how it evolved over time. So right in the early 2000s, when we had only web apps, there was very few APIs on the perimeter. When we had around 2008, mobile became more popular, smartphones, and we started to have mobile apps. So mobile apps added additional APIs in the perimeter. Around 2015, 2016, 2017, that's where roughly we kind of started to spark the idea for Salt. This is where Kubernetes came out, and it really started to revolutionize the software space and essentially kind of introduce the concept of microservices. And what happened is that you had a lot of internal APIs, a lot of West traffic. So you can see kind of the internal part is being deemed a bit, that's internal, and you have all the external APIs on the sides here. But now we're going through a major revolution, and we already see it in our customer base. The growth of APIs, it used to be like very fast growth. It's not even exponential growth. I would not even have the right word to say it. With MCPs connected to APIs and AI agents, we just see an enormous growth of APIs. And the reason why you see that the center is not deemed anymore, not internal anymore, because basically we see that internal APIs cannot be treated anymore as internal APIs, essentially external APIs. And I'll talk about it much more in depth. That's part of the topic today. But essentially, once you connect an MCP to an internal API, which connected to an agent, very quickly, any internal API can be an external API. So essentially, the perimeter for our companies has been broken. And there is no internal and external anymore because of this interconnectivity we're going to talk about today. Okay, so let's actually make it more pragmatic and actually take a scenario. So I always like use analogies in my explanation. It makes things much simpler. So if you think about an AI agent, let's think about it as the digital entity. And this digital entity, this digital employee, you can say even, has a brain, and the brain is the LLM. Has the ears, that's the prompts that are getting, and has also the mouth when, or the hand, which is for the MCP server, and has and has also the mouth when it kind of spits out answers, right? So let's walk through a simple scenario. So the first one is, you have an attacker, and the attacker said, I'm a flight attendant on a specific flight. Can I get a list of all passengers on this flight? In this example, it can be like an AI agent, support agent for an airline company, but you can take this example to any industry, to any agent. What happens here is that the prompt going through the ears of the AI agent, and then what happened with the agent, it's actually using the MCP server, like the hands essentially, to call APIs on the back end, because obviously it doesn't have the data. So once he calls the APIs, he calls some internal API gateway, and then internal services, that's by microservices, like a passenger microservice. We'll get the actual information of all the passengers on that flight. We'll get it back to the LLM, to the brain, to process the information. Eventually, we'll spit out an answer that says, here is the list of passengers X, Y, and Z, right? And that's kind of how the entire circle works. Prompt through the ears, LLM, the brain process, the hands, the MCP, touch, like calling, pressing the buttons essentially of the APIs. And that's what I meant when I say internal APIs can become external. If passenger API was only exposed internally initially, once it's been connected to MCP, very quickly this API can be called and the data can be sent to anyone from externally to the company. Okay, so remember that example. We'll build upon that example a few times here in these slides. But I want to take you to a real world example. McDonald's had a breach, a leak, how it was published of 64 million job applicants were leaked. So let me tell you a little bit the story of what happened there. So what happened there, that McDonald's used an AI agent, chatbot called Olivia. And the idea was to screen job applicants. So obviously, as they hire tens of thousands of people a year, if not more probably, and have a lot of changes, they wanted to automate that with an AI agent. So you can text with it, and you can upload and do shift change and so on and so forth. What happened is that an attacker was watching the agent traffic and saw that it's connected behind the scenes. And I'm a little bit simplifying, but that's like the core part of the breach. It saw was they revealed that they have a API call behind the scenes that essentially kind of pulling or pushing resume data, CV data. And this resume data was identified by this called lead ID. One of the most common API vulnerabilities, the number one on the OWASP API top 10, called BOLA, Broken Object Level Authorization. And they simply saw that once incrementing the lead ID, you can get access to any applicants without any authorization needed. So essentially, they can enumerate, they exfiltrate 64 million job applicant records. Now, what's kind of the moral of the story here? The moral of the story here is actually they bypassed the agent and just went back to the backend APIs. And the risk is that many of the internal APIs, as I said, very quickly can become external because they are connected to MCPs or AI agents sometimes directly. So that's like one big risk. The other big risk is that even in that case, it was not a manipulation of the agent. Very quickly, even if its API was completely internal and not accessible to an attacker, also the agent can be manipulated in order to actually pull all the data and increment this lead ID to exfiltrate all this data. And we're going to talk about some of the risks, but it's becoming real, and we see it more and more. And as you will learn through it, you will see I'm not surprised by seeing these examples. I think we'll see more and more of these. So let's start with the basics. And to me, I always start with questions because saying securing AI, it's a big topic. What are the things, what are the questions we want to ask to help us kind of tackle this problem? So the first one is visibility, right? We want to understand which AI agents we have, and MCP servers, of course, that we have that exist in your environment, which APIs that are connected to, that's the data source. The second thing is capability. What is the high risk actions that these AI agents can do? Right. In the example I just showed you in McDonald's, it was the action of they can push in resumes, CVs, and they can export that as well. Right. So kind of understanding all the actions they can do, that's the capability part. The third part is data. What actual sensitive data is going back and forth? In that case I showed you with McDonald's, there was a lot of sensitive data, right? There's people names, resumes, email addresses, phone numbers, and so on and so forth. So understanding all these sensitive data going back and forth is critical. And of course, what they can do with it. Is it to write it, to read, to delete, and so on and so forth. Posture, the posture of the MCP servers themselves, that's a big topic. We'll talk about it. Essentially, the AI agents, as we said, the MCP is like the hands of the AI agents. So we want to understand what tools, what capabilities they have, and if they are configured correctly. For example, if they don't have any authentication to one of their APIs, means any agent can be manipulated to take over, essentially press any button, quote unquote, and get access to any data. So we want to make sure that the MCP is secured very well. So do we have any misconfigurations? And lastly is attacks. When somebody actually tried to abuse the AI agent, try to manipulate it, try to use it as a proxy to exploit vulnerabilities in your APIs, the question is, can I detect and block malicious actions and any data exfiltration attempts before they happen? So those are like the five big questions I like to ask when it comes to AI agents and MCP security. Of course, there's a lot of nuanced questions, but those are I would say like the big ones to start with.
Let me just interject for just a second before you go to the next piece. Speaking of questions, so anybody that's on, if you have questions, something makes sense, doesn't make sense, you want us to talk a little bit more or go deeper or whatever, there should be a Q&A button depending on how you have your screen configured. Just use that, and then we'll take your question as we're going, or if it makes more sense, we'll do it at the end. But please take advantage of that Q&A option there. Okay.
Thanks.
Yeah.
Okay, so I'll talk a little bit about what Salt is doing in the space, and then I will go into the myth, and we'll actually go and take some myth that I see a lot in the last few months as we are kind of doing it day to day, and I want to break some of these myths. But let's start with, first of all, what we do Salt about these questions that I just asked, right? So I put like the placeholder of visibility, posture, capability, data, and attacks questions. So the first thing we do at Salt is we believe that this is a multi-source context solution required here. So the first source we have is the internet. How do we know what's being exposed? How an attacker find your MCP's AI agents? It starts with the internet. Even in McDonald's case, they saw they have an AI agent on the internet. So what we do there, we have a module called Salt Surface. This is like a specialized ASM for APIs. We reverse engineer mobile apps, web apps, like we scour the internet in a lot of different techniques and get very in-depth visibility. And in that case specifically, we are creating a public MCP server discovery for you. So we scan the internet and we tell you without any deployment, without anything needed, just here's all your APIs exposed, but specifically here's all the MCP servers we see exposed externally to anyone in the internet to be able to probe. So understanding your attack surface. The second part is we have Salt Connect. Salt Connect is an API-based integration, read-only. So it's non-intrusive, it's trafficless, doesn't need anything beyond like a simple link to either accounts, API gateways, and also to source code, like a GitHub to analyze your source code. Completely read-only, completely non-intrusive. And what it gives you, it's three main things. The first thing is internal MCP and API inventory. It kind of gives you a full inventory within a few minutes of all your APIs, but specifically in that context, of our context today, it discovers all your internal MCP servers, all your connected APIs. It's actually analyzing your source code and seeing all the MCP servers, their tools, and so on and so forth. And also we integrate to platforms like Agent Core and Databricks and many others that you host MCP servers and AI agents. It also helps us to address the posture question. So analyzing the MCP itself and see if they have any weaknesses, like hard-coded keys, weak authentication, and anything that can allow an attacker to take over the MCP or to export or exploit any vulnerability through the MCP. Because that's kind of help us on the second question or the third one on posture. On the capability question, what they can do, it's also analyze and create a visual map of all the available tools. When I say tools, it's an MCP term, tools. And they tell you what actions they can do. They can actually tell you, hey, they can, this AI agent, Olivia, can actually insert CVs, can export CVs, can do this, can change shifts. So actually understanding what are the actions that they can take. And then we have, lastly, Salt Collect. Salt Collect is looking at live traffic. We are not in line. We have a lot of different collectors, from eBPF sensors to API gateways integrations to network taps and so on and so forth. A lot of different ways how we analyze the actual API activity, the agent activity, the MCP activity, in order to analyze and tell you what data is going between the agent to the MCP to the API, so you can see the full data in motion. So taking the like what we saw until here, it's like static visibility of posture. That's configuration and source code based or internet based. Here is the actual runtime part. So we actually seen the data going back and forth. And lastly, we have the attacks, all of the detections that we have that we built over the years for APIs and baselining normal activities for APIs. Obviously, an AI agent, it's kind of like a super user of an API. So if an agent tried to access APIs they didn't access before, try to access data it should not access. Let's take the McDonald's example. Suddenly the AI agent or the API is been enumerating a lot of people or job applicants' IDs to get a lot of data. That will be something that we detect and block instantly. So of course, the last pillar is how we help you actually to monitor. So from public visibility, internal visibility, posture analysis for the MCP, mapping actions of the agents in the MCP, identifying sensitive data in motion, and lastly, runtime protection to actually detect and mitigate attacks. Okay, so with that, I want to switch to, okay, let's talk about some of the myth, and let's make it more real. And by the way, I'm used to having much more interactive in general, so I'm happy as you have questions, please kind of submit them in so we have time to answer all of these. Okay, so let's start with the myth. The first one is, and I saw it especially in the early days of LLM security, is that LLM security is equal AI security. Everybody says AI security, but under the hood, it's essentially LLM security. LLM security is essentially, for the ones that don't know, there's a lot of companies that saw a lot of like a wave of acquisitions by the big security companies. But essentially what it does, it's input and output sanitization for your model. So essentially, like if you take the same analogy, it's like securing quote unquote the head. It's like saying, okay, I want to make sure what's the ears can hear the prompt, the input, or the mouth, like the output, and to prevent potential data leakage. But what's the problem with that? The problem is it's not just what the agent says, it's what it does. And I think there is an importance to secure the LLM. But the agent can trigger actions, right? Like we said, like the hands are the MCP and the APIs that can trigger actions. So the fact that I cover the ears or mouth of an agent doesn't mean they cannot do actions. Sorry for that. So like a good analogy is think about like try to secure a car, but securing only the engine without the steering and brakes, right? It's not enough. It's one component. So just as an example, let's take the previous visual that explain the process. Somebody can say, for example, please refund my last purchase, if that's an AI support agent for a retailer. And it might say, okay, refund process, because it's actually calling an API of a refund transaction API on the back end, performing the action, and just answer refund processed. There is nothing sensitive to be sanitized here, right? There is nothing that looks abnormal here, but they still perform the action. So as I said, it's not just about the data, It's about the actions.
Yep.
More so, if we go deeper, I think I have a lot to say about also on data sanitization, why it's extremely hard to sanitize or to protect AI agents using kind of prompt security, or say like prompt, or securing the prompts coming in or the output, just because there is so many different ways for an attacker to bypass a lot of these controls and can do a lot of manipulations. If you have time at the end, in the questions, I can give you a few techniques about how easily you can bypass a lot of the LLM security tools. That's why it's very key to look at the actions.
And maybe I would just add to this before you go to the next one, Roy, is that like the point that you were making was like the LLM had very little to do with what's going on right here. So the agent is the one that's taking an action saying, hey, refund my purchase. And it says, great, okay, it's processed. And that's just calling an API to refund it. The brain, right, or the LLM is not involved really in that at all. And so you could, the LLM still may be completely secure and safe and there's guardrails, but it's outside of that. It's outside of that operating area, so to speak. And so you're still at quite a bit of risk.
Mm-hmm. Okay, I hope I'm not rushing here. The second one is I call like the secure wrapper fallacy. So essentially, I heard from many folks saying, "Oh, but we have MCP wrapping our APIs, and that's kind of secure them, because that's all of our internal APIs is being brokered by an MCP. So it's kind of like making sure they're quote unquote protected." That's obviously not true, right? MCP is a broker. It's not a shield. So as we said, like the AI agent is pretty useless without the hands, without the API to take real action. But essentially, MCP is just a protocol that just brokering the API. Like a good analogy is, think about if we said like the APIs are the hand or the MCP is the hands. The fact that you have you standardize the glove, let's call it like that, doesn't mean that if you have a broken lock, it cannot unlock it or kind of open it and take the data. If you have a vulnerability in the API, the MCP will broker or will proxy that vulnerability as is to the agent. It's not gonna interfere or add a layer of security to it at all. Actually just creating more risk to it. So just to give you an example, again, and I'll use that visual as much as I can. If somebody says, tell me all the customer records that created today, it will go to the MCP, the AI gateway, the API gateway. And if you have, let's say, it's connected to an internal APIs, and this internal APIs is basic auth, by the way, very, very common. We see it all the time. Static authentication. So the user doesn't need to provide any authentication. But the AI agent has access to internal APIs. So they can actually fetch all the data. They have the access to it. They have the authorization for it. They don't need it from the user. Pull all the data out and then returning all the customer records. So basically, if you have a vulnerability on the API, MCP or AI agent is not going to protect you from the vulnerability. Vice versa. They will make it exploitable for someone external to the company, unlike before that you needed to have some level of access to the company perimeter. Now you don't need to have anymore. You can use them as a Trojan horse, essentially. Okay, I'm going to the third one. We're going to have total of 4 myths, so try to keep it light and short, so we have time for question, have a discussion here. So the third myth is I call it like the myth of the single choke point, and essentially is that I can secure AI agents with all of its complexity just using what I call a single context tools. So when you look about the reality is, and when I say context, I mean it's the type of data we are monitoring in order to secure those. So for example, a gateway, like an AI gateway, will see only traffic, but it's blind to what exists in the code, the logic in the code that might have hard-coded keys, might have what's been configured actually, what's the developer wanted that the MCP can do. So they don't see it, they see only the traffic. And you have some scanners that looking at the code, or some posture and AI tools that looking at the code, they're not looking at runtime. So they are blind to attacks and data in motion, so on and so forth. So what I'm trying to say here is that the solution is not it cannot be solved just through one type of context. It's actually, we believe at least, that you need to have like what we call triple context. You need to have the code, so you understand what the agent is programmed to do. And to identify a lot of flaws, you can only identify from code analysis. But it's not enough. You need to look at the configuration of the tools, like the database and the agent core and the AWS and so on and so forth, to validate that they can actually access what they're allowed to access. And lastly, you have to have runtime. You cannot monitor data in motion. You cannot monitor in actions. You cannot monitor real live attacks if you don't have the runtime part. And runtime, I'm saying it's on the API, on the MCP, and all the communication between agent, MCP, and APIs. So we believe you need all three of them in order to really secure most of the use cases around AI agent security. If you look at one, I think you're going to miss a big part. You're always going to lose something if you're going to look only in one source. So that's kind of what I see as many people try to solve it only through one angle. The reality is a complex problem, and you need solutions that looks at multi-layer of these contexts on top of each other. The last part, and with that, I will almost finish. I'll take you another 5 minutes of your time, and then we go to questions. I call it like the myth of the distant horizon, and that's probably the most common myth I see. And what it means is, we don't have urgency because that's a tomorrow problem, right? And mostly like their arguments is, we are not in production with these AI agents. They are in labs, in experiments. They are in RQA. They are in dev. So they're not really creating a risk for my business yet. Like, we agree it's very important, but not today. And I'll say here something that I think you, as security professional, have a huge opportunity. And I would say I call like the interest of security debt, like tech debt. You have security debt because these MCPs are being developed as we speak. And at some point, they will reach production. And I think it will be quicker than what we think. And if you wake up and you have hundreds or thousands of MCP servers running around, connecting to tens of thousands of APIs, and they're poorly written, poorly secured, you have a lot of bad authentication, a lot of open internal APIs, no auth, and things like that, you'll find yourself with so much what I call security debt. And it's so much harder to fix something after it's been deployed in production, right? You need to go back, and it's much harder to do it. So my recommendation is start with MCP security. There's a lot of problems about AI agents, and even us at Salt, we solve multiple problems around AI agents. But let's say, what do you get the best ROI? To me, is the MCP security. And why is that? Is essentially kind of we call it like virtual handcuffs of the essentially like the virtual handcuffs of the AI agent, right? Think about in the real world. What are you doing when you try to neutralize a risk, like a person, a criminal? You put handcuffs, right? That's immediately reducing the risk of what any malicious intent can do, right? So it's very similar. You can, if you start with good MCP security, means like you limit what actions the AI agent can do. You make sure that it's been built very securely. Even if someone tried to manipulate it and the agent actually try to do, let's take the McDonald's example. Let's say that agent would have been manipulated to exploit or to exfiltrate all these data. If the MCP and the and the API security side was solid and it had no vulnerability, there was no vulnerability to be exploited. So I think putting these digital handcuffs is the very first thing. The very first thing I will do. Okay, so lastly, and I promise that, we always want to give more value than just knowledge. So hopefully that was pretty knowledgeable for you and valuable for you. And I'm looking forward here to the questions here in a second. But we want to give always something back. So from this entire journey, I describe what we do at Salt. Salt Surface is the part that is completely external. It doesn't require anything from you, just saying, I want to run a surface scan to discover your public MCP. So what we did here, we put actually a QR code. You can see the link. And we are offering to anyone that registered and actually attended the webinar a free scan. It doesn't require anything besides saying, scan me and put your domains, and we will come back and show you a report of what you look like, what your attack surface looks like, and also what MCP servers we see exposed externally, free of charge. just want to give value back because I think it's great to start the journey now versus later, so you don't accumulate any security debt. So I'll pause on this screen, so I'll give you a second to scan it or to copy the URL. But I think with that, kind of finishing sooner. I know we booked an hour, but I wanted to leave time for questions. So MC.
Yeah, so I would just remind everyone, please do you scan this. It's a really insightful report, and like Roy said, you want to look at your MCP servers often as a first step, and this report will actually find those for you when we do the scan for it, and it's totally free, super quick. We'll run through it with you, and it gives you a little bit of a path or a roadmap on where to address and where your risks are. Roy, there was one question that came in. It had to do with the cloud environments, and it was, is anything that we do specific to any particular cloud environment? Is it Azure, Google, AWS?
No, completely agnostic. Completely agnostic to any cloud environments. Yeah, it's
okay.
It doesn't matter. It's not even cloud production system on-prem data centers. It doesn't matter if you have an F5 or load balancers on-prem or in the cloud. We support all of them.
Yep. The another question was, I'm kind of paraphrasing this, but it was how long does it take to get going, right? So it's complex technology. APIs are MCP servers, agents, LLM, all of it is kind of complex. But how long does it typically take someone to get moving, to start to get some sort of visibility or value or what have you, like insight into their agents?
Yeah, so it's actually take pretty much zero time, because like Surface is the first stage, the first part, and it's completely passive and external. We're not even probing your environment. We are actually looking online. So we scan public GitHub repositories. We look at mobile apps that you have in the App Store. We look at web apps. So we have a lot of different techniques of seeing your digital footprint in analyzing what APIs and what MCP servers are exposed. So it's completely, very quickly, just give us a domain, and the next day we're going to meet with you and we will show you the results of the scan. That's very easy. Connect site is also super quick. It's like I said, it's a read-only based only API read-only access. So it takes a few minutes. Literally, it's self-serve. You can click and you can connect your entire multiple clouds in a few minutes. And instantly you get instant visibility and governance across all your environment. It's not going to monitor for attacks. That's not runtime. But it'll give you instant visibility and governance for your entire environment. And then you can choose, here I have a critical agent, I have a critical MCP, critical APIs. I want to monitor those specifically for attacks and for data security. And then you can be much more targeted where you want to put an extra layer of security, of monitoring.
Yep. There's one more, and I'll just remind everyone to please use the Q&A button, and we'll keep going. But there, one more is, and it's written a little bit complicated, but it has to do with integrations. And so this is maybe even more to just APIs in general, but I think it relates to AI agents, integrations to other technologies, other SIMs, firewalls, WAFs, what have you. Is there any type of integration to kind of share this when you go through the discovery and you find this information? Is there a way to share it, or how do you share it?
Yeah, of course. Look, we believe that, like, as an approach in the company, in Salt, we led the approach that we live in an ecosystem. We have to give you the experience of a full platform that plays seamlessly with your entire ecosystem. So, and I'll just pull up one slide because I feel like there was a lot of questions around it. But essentially, we are connecting to any SIEM solution in the market. We have a whole workflow automation inside our product that you can actually configure any data that exists in Salt. You can have it in any other tool. So from your ticketing systems like ServiceNow, from SIEMs like Splunk, next generation SIEM of CrowdStrike, from blocking integrations, anything you can think about that has an API, we can push data, we can trigger actions, we can create workflows to kind of fit seamlessly within your ecosystem. So you can see here, by the way, Surface, Connect, Collect, Protect, that's like the stages I described. And you can see some of the logos, really like a sample, because we don't have enough space here, of things that we support. But the reality, the list here is on the Connect is very long. On the Collect side, we have over 7 plus collectors. On the protect side, it's in the hundreds, to be honest, because we have a lot of examples from our customers.
Perfect. Okay, I don't I don't see any more. If one happens to come in as I'm wrapping this up, I will stop. But I wanted to thank everybody for joining. It looks like everyone stayed from the beginning all the way to the end. So hopefully it was interesting content for you and you learned a lot. I'll remind you that you can always go back and look at this. It's always available on demand. We'll also send out a link to the recording by the end of the day, maybe early tomorrow. You'll get it based on how you registered, but we will get it to you as well. And you can always forward it to your friends. You can look at it on demand at any point. And if you ever have any questions, just go to the website, click the contact us button, and we'll get back to you within a couple of hours. Thank you, Roy. Super insightful as always. Thank you all for joining, and we look forward to seeing everybody in the new year. Thank you, everyone.
Thank you very much.